In a bold proclamation, researchers have announced that they have identified a celestial object unlike any previously recognized. NASA, celebrated for its pioneering discoveries, has disclosed that this planet is compelling not only because of its size and position but also due to its emission of light that appears to be artificial. Could we be on the brink of uncovering hidden truths that might deeply alter our comprehension of the cosmos? Could this discovery imply the possible existence of life on other worlds? By analyzing NASA's trailblazing findings, we will soon reveal the realities behind this extraordinary event. In 2007, NASA launched the Dawn mission with the goal of exploring some of the most fascinating entities within our solar system. Equipped with 3 ion propulsion systems, Dawn began its journey with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn transmitted back exceptionally detailed images and data, illuminating Vesta's complex surface and diverse geological history. Upon completing its mission at Vesta, Dawn advanced to the next phase of its voyage, one that was likely even more exhilarating: a thorough examination of the dwarf planet Ceres. Thanks to its ion propulsion systems, Dawn was able to break free from Vesta's orbit and head toward Ceres, a feat that would have been unattainable with traditional chemical propulsion methods. These propulsion systems provided consistent thrust, enabling Dawn to traverse vast distances and establish a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt situated between Mars and Jupiter. For 4 years, it was classified as the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres stands as the largest and most massive body in the asteroid belt, one of the most captivating due to its unique characteristics. Scientists eagerly anticipated the first close-up images of this enigmatic planet, which revealed brilliant spots scattered across its surface, particularly in a large crater known as a crater. These luminous spots ignited immediate curiosity and speculation within the scientific community. Prior to the Dawn mission, the best images of Ceres were blurry, low-resolution photographs taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the promise of detailed observations from Dawn fueled excitement among astronomers and space enthusiasts alike. The Dawn mission aimed to enhance our understanding of the solar system's formation and investigate the role of water in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, might be composed of highly reflective materials, possibly salts left behind by evaporated water. This discovery hinted at the possibility of cryovolcanism, volcanic activity that erupts water or brine instead of molten rock. But what exactly are these enigmatic lights? And what do they reveal about the true nature of Ceres? Could they be signs of ongoing geological processes or something even more extraordinary? Ceres stands out from other objects in the asteroid belt due to its size, mass, composition, and the potential presence of water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a significant milestone as it prepared to offer the first detailed views of the largest body in the asteroid belt. As Dawn neared Ceres, the images became progressively sharper, revealing a world previously hidden from view. The initial photographs showed a cratered surface, suggesting a long history of impacts. However, what drew the most attention were the mysterious bright spots amid the dark, rugged terrain. As the image's resolution improved, scientists began to formulate theories about the nature of these spots. Were they areas of ice reflecting sunlight, or could they be something even more remarkable? Speculation ranged from mineral deposits to possible signs of cryovolcanic activity. To everyone's astonishment, closer examination showed that the brightest spot wasn't just one feature, but a collection of distinct areas. The most widely accepted explanation was that these were salt deposits left behind after water sublimated. This suggested that Ceres had, or possibly still has, some form of geological activity capable of pushing water or brine to the surface, where it rapidly evaporates, leaving behind bright reflective residues. These findings challenged previous ideas about Ceres, painting a picture of a more dynamic and intricate world than anyone had imagined. The potential existence of subsurface water or brine pockets could have profound implications for our understanding of the possibility of life elsewhere in the solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are largely composed of rock and metal, Ceres stands out for its distinct composition. Its surface is a blend of water ice and hydrated minerals, including clays and carbonates, giving it a less dense structure than its rocky neighbors. This composition suggests that Ceres may harbor significant amounts of water beneath its surface. Its outer layer is rocky but porous, with trapped ice and other volatiles, making it resemble a comet more than a typical asteroid. It is believed that Ceres has a unique internal structure consisting of a rocky mantle and a core rich in water ice, which makes up about half of the planet's total volume. Ceres' mantle is likely a mixture of rock and brine, surrounding a denser core possibly made of silicates. The presence of substantial amounts of water ice raises the possibility that Ceres may have once supported liquid water, especially if its core was heated by radioactive decay during its early history. This internal composition distinguishes Ceres from adjacent asteroids and presents intriguing inquiries about its capacity for geological processes and the influence of water in its evolution. But there's more. The detection of ammonia-rich clays on Ceres implies that this dwarf planet may have originated in the frigid outer regions of the solar system before migrating inward. The existence of ammonia could depress the freezing point of water, permitting briny fluids to remain liquid on or just beneath the surface. These revelations regarding Ceres' makeup and past not only broaden our comprehension of this captivating dwarf planet, but also offer essential insights into the mechanisms that govern the formation and transformation of icy celestial objects throughout the solar system, the future of space exploration and what lies ahead. Cryovolcanism is a captivating and relatively rare geological occurrence, especially when compared to the more common volcanic activity seen on Earth. Instead of expelling molten rock, cryovolcanoes or ice volcanoes discharge elements such as water, ammonia, or methane. These compounds can persist in liquid or gaseous form in extremely cold environments. On Ceres, cryovolcanic activity enables salty water to rise to the surface. Upon encountering the vacuum of space, this saline mixture rapidly undergoes sublimation, shifting directly from a solid or liquid to a gas. What remains are shiny salt deposits, which manifest as the puzzling bright patches seen on the planet. The most notable of these glowing regions is found in a crater, specifically in a section nicknamed Spot 5. This area has garnered significant attention due to its exceptional brightness and observed temporal fluctuations. These variations are thought to be connected to water evaporation, implying that cryovolcanic activity might still be occurring or happened relatively recently. Besides Spot 5, Ceres features numerous other radiant regions, each displaying unique properties. These aren't confined to a single zone but are dispersed across the dwarf planet's surface, signifying that cryovolcanism might be widespread. Their presence underscores Ceres' dynamism and refutes earlier beliefs that it was a lifeless, inactive body. As the Dawn mission persisted in delivering increasingly refined imagery, it unveiled a terrain dotted with impact craters, each telling a segment of the celestial body's narrative. Expert interpretations, hypotheses about the new frontier. These findings have radically altered our perception of Ceres. With its icy composition and indications of active cryovolcanism, the planet is now viewed as a vibrant and evolving world, no longer merely a frozen remnant from the past. The brilliant areas, particularly those within a crater, continue to captivate scientific interest. They may represent not only surface-level geological activity, but also deep-seated processes that suggest Ceres could maintain underground reservoirs of water. Studying Ceres offers broader implications than merely understanding one dwarf planet. By examining its inner structure, surface irregularities, and reflective residues, scientists can extract valuable clues about the behavior and development of other icy celestial bodies in the solar system. The materials discovered on Ceres, such as water ice, ammonia-infused clays, and shiny salts, may illuminate the chemical compositions and environmental mechanisms of similar planetary systems. Moreover, The possibility of cryovolcanism opens exciting new directions in comprehending geological dynamics not only on minor planets and frozen moons within our solar system but also on distant exoplanets. This points to the potential that areas once considered sterile and inhospitable might, in fact, support complex natural processes. Could this also imply that remote worlds, previously dismissed as cold and barren, might possess the essential conditions for life? Final thoughts on NASA's Dawn project. Its meaning for humankind. NASA's Dawn mission remains a glowing testament to the power and promise of space exploration. The knowledge it provided has already shifted scientific paradigms concerning the genesis and transformation of our celestial neighborhood. As we probe deeper into the mysteries of Ceres and comparable distant objects, each data point contributes to the grander mosaic of how planets, moons, and other stellar bodies originate and evolve. At present, the luminous features on Ceres rank among the most intriguing riddles in planetary science, but they may only represent the start. With advancements in technology and the deployment of new exploratory missions, the likelihood of uncovering even more revolutionary insights continues to grow. Ceres, once regarded as an insignificant speck within the asteroid belt, now emerges as a beacon of fascination and potential. Its varied landscape, layered interior, and enigmatic glistening spots may eventually unlock answers about our solar system's infancy and the forces that shaped its worlds. The possibility of microbial life, or at least the fundamental components needed for life, on Ceres remains an electrifying prospect, fueling continued enthusiasm among scientists and space admirers. As our journey into the cosmos progresses, the lines between fiction and reality blur even further. What was formerly the realm of science fiction, the existence of alien life, has matured into a valid scientific query. Could microscopic organisms thrive in Ceres' hidden aquatic reserves? Might the environmental conditions present on other frozen celestial bodies support life forms either familiar or yet to be imagined? These are the questions that will drive the future of space inquiry, and perhaps one day unveil profound truths about our place in the universe.